So.
Okay, good morning, everyone. Thank you so much for joining our meeting this morning. My name is Stephanie Singer. I work with the ag team at the Nature Conservancy in Ohio in the Western Lake Erie Basin. And we're really excited to have a discussion this morning about the Haney soil test, answer any questions that you might have. I think that what we're going to do, we're going to start off just having some of our co-hosts here give a brief description of who they are and their background, and then we'll go from there and answer any questions that you have. So first, if we could have Rick Haney give us some information about himself and this test that we're talking about today.
Hello, everyone. I work for USDA ARS and retired a couple of years ago, actually about almost 3 years ago because of COVID. But I developed this test many years ago because the thing that was bothering me about soil testing was that it included no biological component. So it was just, a bunch of chemistry, and that's fine, but soil is actually alive and we need to account for the biology that actually drives the chemistry. So that was a missing link that needed to be filled. And so one of the fun things about it is that we're seeing at microbial activity, we're seeing the food source that they're feeding on, which tells us about your management. So we can help, steer things towards like cover crop mixes, maybe go into no-till, something like that. And that has an effect on what we see. And I think the national average, I work for Regen Ag Labs, Lance Gunderson right now, part-time in my retirement. And between his data and my data, it's about 100,000 samples. We've seen an average of $20 savings in nitrogen that we don't have to put on. That's just an average. A lot of that's higher. And so that's a really important aspect of including the biology. And so we also developed a soil extractant that mimics what a plant root does, because what we're trying to do with this test is mimic what's happening in the field, because it doesn't really matter all that much what we can do to soil in a lab. We really need to know what's happening in the field. And so that's the main difference between a standard soil test and then what we're doing. That's all I have. I'm having a little trouble with my bandwidth. This is why I'm just on speaker.
Nope, we can hear you great. At least I can hear you great. Is everyone else? Yep, good.
Yeah.
Okay, and then next, thank you, Rick, very much. We appreciate your participation in this and your background and thoughts on this. Carolyn, would you like to go next?
Yeah, my name is Carolyn King. I am the lead agronomist with Continuum Ag. So I spend the majority of my time looking at Haney tests. Continuum started using the Haney test in 2015, mostly to just help farmers understand how healthy their soil is. We've developed a lot of systems around that since then to write better fertilizer recommendations. So like Rick was talking about, one of the things that we track is how much money people have saved on fertilizer by using the Haney test. So spend a lot of time looking at the test and digging into the different aspects of it with the farmers, and then helping them figure out how they can optimize their fertilizer recommendations because of that. I know it said that this is with Mitchell today, but Mitchell and his wife had a baby on Saturday morning, a little boy. So you get Rick and myself, but I think we'll be able to make it and answer all your questions.
Thanks, Carolyn. And then finally, we have Matt Burkholder here. He is both part of the Farmer Advocate for Conservation project as a farmer, and he has recently begun working on staff with the Nature Conservancy to help us facilitate this project. And so Matt's just going to talk a little bit about why we're using this test.
Hello, everyone. Like Stephanie said, my name is Matt Burkholder, and I have found the Haney test to be very helpful. Obviously I'm just learning, and I'm nowhere near where Rick and Carolyn are. But I sat down last week with a landowner and I just showed them my Haney test that I did and another Haney test that I did on a field that wasn't utilizing regenerative ag practices. And it was a very, very good educational tool, a good way to compare the different systems that we're utilizing. And so I really appreciate Rick and Carolyn and the time they've taken out today to help educate us more about this.
Yeah, thanks, Matt. And one of the goals of the Farmer Advocate for Conservation Project, for those of you who are, I know some of you are involved in it, so sorry for the repeat here, but really what we're trying to do is elevate the voices of farmers who are using regenerative practices on their farm and connect farmers with each other that want to do that. And so research has shown us that farmers want to learn from each other. And so the Farmer Advocates for Conservation project, we find farmers that are excited about what they're doing on their farm. We have developed a training that they went through that helps them communicate better, learn about their audience, and kind of like meet that farmer where they are. So wherever they are in the process of either beginning cover crops, advancing with that, or other practices, and then forming peer groups around that, or just forming relationships with farmers that so they have someone that they could talk to and bounce ideas off of. And so the Haney test is just one other tool that we're using to facilitate these peer groups. So here's the results of the test. How do we understand them? How do we use them? Someone asked me to put a link for the Farmer Advocate website in the chat, and I will do that. And if you Google it, Farmer Advocate for Conservation, it will come up too, but I will share the link. I would like to open it up now for people who have questions about the test. And so you're welcome to come off of mute and just start talking, introduce yourself, you can give a little background and then talk about your question, or you're also welcome to put it in the chat. I'll be monitoring the chat. Who's first? Don't be shy.
Well, I'll jump in. It's all right.
Jump in.
Okay.
That'd be great.
Yeah, I have 200-acre farm. We have 60 crop acres. And the original farm we had has like 50 crop acres, and the farm we bought next to us 30 years ago had not been tilled for a long time, and the soil health on that is double what it is on the farm that we had conventional ag for years and years and years and years. I mean, it's just phenomenal. In 2019, went full bore, switched the whole farm to regenerative agriculture, as well as our woods is under conservation plans with the DNR, USDA, et cetera, et cetera. And I've used nothing but the Haney soil test since 2019. It's hard to convince people to change. But Rick, could you give more detail about, you test the biology, not the chemistry. My understanding is that Haney soil tests use water extraction and not chemical extraction. So can you go dive a bit more deeper into that science between, conventional testing at the land grant universities or wherever people send them compared to the Haney soil test? Because when I try to explain this to people, I'd like to be a bit more articulate about it, about the difference. And I know, like Matt said, and everybody said that financially it does make a vast difference of telling what inputs, suggesting what inputs need to be, would be helpful. But could you dive a bit more deeply into the science?
Yes, Jan, yes, I can. So yes, we use water, but we also, we test both the biology and the chemistry. It's not just a biology by itself. We run nitrate, nitrogen, orthophosphate, all the same things that like a university lab would run. We run all those same components. However, the difference is they use chemical extractants that were developed in a lab to try to just get as much nutrients out as possible. And that's not how nature works. Nature doesn't just throw all the nutrients out there at once and just sit there. So it's a constantly cycling system. The biology is involved. And so we developed an extractant that's not super harsh. It mimics what a plant root does. So plant roots
Okay.
When they need something, some nutrient or whatever, they will manufacture or organic acids within their system and drop those out their roots, which the microbes respond to, and all kinds of different things. And so it's called H3A. It's an extractant that is a weak acid, and it mimics what a plant root does. And the reason that's important is because the pH of the soil is very important, and that kind of drives nutrient availability. So when we take a soil and take it to the lab and hit it with a artificial, very strong acid, then the pH of the soil doesn't matter anymore. We've altered that system in the lab, and we're not really showing what the soil's doing when a plant root's growing in it. So the Haney test is designed to look at nutrients from an aspect of, this is what a plant root would see, what a plant root would do. These would be the nutrients available based on these natural systems. So when we combine that with the biological input, the rest of the soil respiration, because microbes take in O2 and give off CO2. So we measure the CO2 to look at that. And then we do a water extract because it rains water. Well, it doesn't in Texas, but it used to. And so that's the environment they find themselves in. So we do a water extractable organic carbon and water extractable organic nitrogen, because those are two components that that's the microbial food so that they can reproduce themselves. But then, so we do two extractions. So one's water, one's H3A, and H3A, you get phosphorus, potassium, micronutrients, and all that stuff. But that's based on the natural release of organic acids from plant roots, if that makes any sense.
Oh, Jan, you're on mute.
Sorry, I didn't want to. So do you use the same soil samples for both of those tests, or do you use a separate soil sample for the chemistry and a separate one for the biology?
No, it's the same sample for
That's
both.
what I figured. Okay, that's why I was curious. Okay, all right.
Yep, because and we also, it's the whole thing's based off the standard 0 to 6, that everybody's used to doing. So, and I want to make this point that we get a lot of samples coming through Lance's lab that are like 0 to 12, which is fine. But if you're going to run a Haney test, don't do 0 to 12, because the majority of the activity of microorganisms is in the top 6 inches. That's why the 0 to 6. So if we take a 0 to 12 inch sample, we're just diluting the effect. I can look at results and I can see the organic matter, and then I can see the respiration. And it's like, if let's say it's 4% organic matter and the respiration is 20, I'm like, that's too deep a sample. And I'll scroll over to the right. And sure enough, it'll be a 0 to 8 or 0 to 12. So they're very sensitive. It's a very sensitive test. And people sometimes have trouble with it being what they call variable, because biology is variable. So it's very important that if you take a sample, take it at the correct depth and don't overshoot that.
Okay, thank you. That's really great. I'm really glad to be here. Thanks so much for this. This is
Me
awesome.
too.
This is awesome.
Who's next? Gary, you're off mute. Do you have a question?
I need somebody to go over this with, I guess, because I don't understand all the symbols. I mean, it's got a recommendation, suggested cover crop, 60% legumes and 40% grass. But the rest of this, I got like a 14.2% soil health. I haven't, all of them are just kind of low in the green, as far as that graph.
Gary, the national average for soil health is 7.
Oh, okay.
Yeah.
So that means it doesn't look like it looks like I'm almost in the yellow. It's what it's.
Well, that's Brookside's scale, and so, that's, we don't kind of do it that way, because we don't want farmers saying, oh, well, my soil health is 6, and the other guy saying, well, mine's 18, because it really matters where you are in the country.
I see.
So we really don't want to, for example, in Iowa, an average soil health score might be 14. But in New Mexico, it might be 6. And that's not because, you know, Iowa's a great state and New Mexico isn't. It's because of the geology that they find themselves in, the lack of rain. You know, a desert soil is not going to have a high soil health. You know, so it matters where you're at. And so
Okay,
we never wanted to get people to competing with each other because
right.
the soil health number is important, but it's not, I could care less what your soil health number. What I want to know is, are you feeding your microbes a good carbon source? Are they responding to it? Are they giving you free nutrients that we can utilize to reduce fertilizer inputs? And I want to say, we're not anti-fertilizer, we're anti too much fertilizer. We want farmers to be able to be efficient with their inputs because that's better for them, that's better for their pocketbook, and that's better for the environment.
Yeah, the bottom line.
Fertilizing is not helping anybody.
Yeah, the bottom line is the dollar. I mean, that's what you want to save
Yep.
as much as you can. Another thing is, I didn't hear much more about carbon credits and things like that. I don't know where they're at that. Maybe you don't know either, but I know some of these elevators will pay a little bit for the carbon credit on these.
Well, we can talk about carbon credits if you want to. I'm not a big fan of the way it's being done because we're just, doing a 12-inch sample and saying, oh, here's your organic carbon. Well, I don't even know what that means because carbon, so everybody knows that the sun shines, right? And the plant takes in that sun energy and it pulls CO2 out of the air to produce itself, to grow a plant, use that carbon to leak to feed microbes. All these things happen to capture carbon, right? So what my approach is, it's like, no, we need to credit the carbon that the microbes have that is in the system that's being cycled. So we want to do the gas, liquid, and solid phases of carbon as a carbon credit. We want to develop the whole system for the farmer. And I think the farmer ought to be paid on the whole system. So if you have a good soil health score, that directly reflects how good your microbial activity is, how good the carbon is that's coming into the system, and I think you ought to get paid for all that carbon that's captured, not just, let's just do a 0 to 12-inch sample and measure the carbon and call it good. I think that's a ridiculous way to do it. I didn't used to be able to say this because I used to work for USDA, so it's super funny.
You probably should talk to Biden then or something, get him straightened out.
I don't think he would understand.
Probably not. Yeah.
So one of the newer things that we've been working on at Continuum is kind of with this carbon credit stuff, but it's really shifted quite a bit. And like Rick was saying, it's more focused on the whole system, not just storing this supposedly stable carbon in the soil. So the kind of newer thing is called low CI scoring. CI is carbon intensity, and it's basically looking at what is the carbon score of your entire farm, and then are you below the national average? If you are, then that's how you get paid. So not just looking at how much carbon is in that 0 to 12-inch sample, but how much carbon, or what's your carbon footprint of everything that you're doing on that farm. Mitchell explains it way better than I do. I'm definitely not the expert on it, but what I can tell you guys is that it was signed into law to be used starting January 1st, 2025. It came in with the Inflation Reduction Act. So basically what the Inflation Reduction Act says is that these biofuel companies can get a tax credit for using low CI grain and producing low carbon intense fuels then. Sorry, it says my internet connection's unstable, so hopefully you guys can hear me okay. Stephanie, am I breaking up or?
Picture went away.
I can hear you good. Is everyone?
Okay.
Yep. And Caroline, if you have something that you want to share your screen, just let me know if you have something.
Yeah, I don't think I have any CI slides on my computer, but I'll just kind of briefly talk about it. And then if you guys have more questions, we can get time set up with Mitch or Justin and they can dig into it deeper. But basically what a program like that is trying to do is say, okay, the biofuel company can get a tax credit for producing this low carbon grain. Therefore, you, the farmer, should get some kickback from that because you're the one who's providing the grain that then gets the low carbon fuel. So we're trying to navigate all of that right now. It's still pretty muddy waters, but basically the key thing is if you're using cover crops today, you would be eligible to participate in that in the future. That's very different from the carbon offset programs that we're familiar with right now. Any of you that have been using covers in the past, you're not eligible for these
Right.
programs that are around today. With this low CI stuff, you would be. So that's kind of a key thing to take note there. The other piece of it is that, like I said, it starts taking effect January 1st, 2025. So if you're not using cover crops yet, or you don't quite have that figured out, now is kind of the time to do it because the crop year goes from harvest to harvest. So if we can start selling this low carbon grain January 1st, 2025, that means that the cover crop practices you do this fall are important because they're a part of your 2024 crop year. So it's just something to kind of keep on the radar. Continuum has a bunch of resources on our YouTube page about CI that explain it much better than I can. I'll drop the link to that in the chat, but basically, Gary, the answer to your question is that the carbon offset stuff hopefully is not going to be as big of a thing anymore, and it'll be focused on the carbon footprint of your whole farm instead.
Yeah, Carolyn, that's how I understand it, that they're looking at how much diesel you're using,
Yeah.
you know, how much. So the low carbon intensity score means that it's not taking you near as much. You're not blasting everything with carbon to grow 300 bushel corn. And so it's if I'm understanding it right, it's like, how efficient are you at using the carbon to develop the right crops? I mean, something like that. I mean, it's pretty interesting.
Yeah, because I know I talked to Cargill, they had like a program carbon credit, and it was like if you did have any kind of cover crop before, that field was not qualified. If you didn't, then they could use it. So yeah, this sounds a lot different than what they are doing right now.
Yeah, Carolyn just put a link in the chat.
Yeah, so that's to our resources about carbon intensity. They're longer videos with various people just kind of discussing how all this stuff works and explaining, you know, what it'll mean for the farmer. So if you guys want more info on that, that's a good place to take a look.
Yeah.
Do you guys tie in with H2 Ohio at all much, or are you bring them any information there?
So the carbon intensity stuff would not be related to the H2 Ohio really at all. And Matt or Stephanie, you guys can probably speak to this better than me, but can the Haney test be used in the H2 Ohio program? I don't think it can.
No, it cannot. I've argued that a little bit, you know, thinking if H2 Ohio is trying to promote soil health, then the Haney test needs to be part of your nutrient management plan, but currently it is not.
Yeah. So this information about the low CI scoring, that's great. If you want to learn more, you can go to that YouTube link that Caroline provided. And then I mean, there is some other person in the comments saying they want to know more about this. So I feel like we should probably have a whole other lunch and learn or event really just centered around this topic. And I know they're super related, but I do want to make sure that people who are on the call who did the Haney soil test and you have your results in front of you, if you have like specific questions about that test or that you have a chance to answer or ask those questions now. Also.
Well, and I'll say this, and I made this statement up in Omaha. We were up there recently, and I said, look, soil health and carbon capture are connected. You can't increase your soil health without capturing more carbon. That's just not possible. It's not how it works. So it's not like we need to worry too much about all these carbon programs. The main focus is to change your management if needed to increase that soil health score on the Haney test, because that everything just goes together with it. that's not disconnected from carbon. The way they're selling carbon is kind of disconnected from going on. So there's a lot of work to do on the whole carbon thing. And because, I want the farmers to be in charge of their carbon and being able to sell it and whatever, and not just, measure one thing and say here and, give us your money. And, there's a lot more that needs to be done and needs to be done intelligently. Because we want to see soil health increase, which it helps with the water cycle, helps with the nutrient cycle. We're not putting on excess nitrogen. I mean, these are all win-win scenarios.
Yeah, definitely. And having, I think it's what we're doing here and what we're all advancing on together is having the farmer have that understanding of their soil, so they know not only about how to manage their farm, but they could also have a good understanding of where they fit into some of these programs.
Yeah, because if just like that, you guys are talking about, well, if you're already doing cover crop, you don't qualify. Well, that's just ridiculous. Like, why would we do that? And so if you look on any soil test result, I don't know if Brookside does it, but Region Ag Lab does, but there'll be one little calculation there. It's called organic to inorganic ratio. And what that means is this is how much organic nitrogen is in your system compared to your inorganic. And when people switch from a conventional system to a regenerative system, that's one of the first numbers we see to start to move. Usually, the majority of your nitrogen is in the inorganic form, which would be nitrate and ammonium. And what we want to see is that start to transition. We want to see the majority of your nitrogen in the organic form, because that's less susceptible to leaching and denitrification and all that. So if it's in the organic form, that means the microbes can break it down, deliver it to the plants when they want to, because the plants and the microbes work together. And so we don't want to, distract that interaction. We want that system to start to work together. It's like an engine that's, finally gets broken in and then everything moves smoothly. That's what we're really after with using this type of testing to see what's happening on your fields and what it needs to do to get to that optimum efficiency rate. We also do the same thing with phosphate. So we look at the total phosphate, the organic and inorganic, and what those ratios are. We look at the organic, water extractable organic carbon to nitrogen ratio. That's very important. That's very different than your soil carbon nitrogen ratio, because the soil carbon nitrogen ratio is a huge pool of carbon and nitrogen. But what we're focused on with the water extract is the C to N ratio that the microbes are feeding on. That is much more important. We've seen a number of samples that'll have, let's say they're both 4% organic matter, they both have identical organic matter, but they have very different microbial activity, water extractable organic carbon and nitrogen. So those are two very different systems, even though they look like with a standard test that they're the same, and they're not. And so that's really helpful to start to understand where you're at in your journey. And it's really tough to look at. Just can't get that information from a standard soil test. They don't have the components. So that's what's new and different. And that's what people are, struggling with, because they're just used to, well, we have this much nitrogen, phosphorus and potassium. Well, that's fine. How much of that is active? How much of that is in play? How much of that are you applying that you don't need to, because, the microbes are cycling nutrients. And so that's, it's a whole new ball game. It's a very different way to look at soil. And I told my wife that before I die, if I could just get the message out that your soil is alive and that we need to treat it that way, I think that would be a big step in the right direction as far as our management of this precious resource. How was that for my stump speech?
Yeah, we need to pull out some of these quotes here, Rick. We do have a question in the chat from Jay Mears. He says, this is a first soil test I've seen that shows soluble salts. What does that mean?
Well, so, okay, so soluble salts, if you have like super high, if you put on a bunch of nitrate fertilizer, your soluble salts will go really high. Because when you put on fertilizers, you just don't put on nitrogen. You put on what they would call a salt. So like potassium nitrate, the potassium would be the salt in that. So there are other salts that are associated with various chemistry, and you don't want to see high soluble salts. You want that to be low. So if I look at a result, see high soluble salts, I go looking for what it is.
What's considered high?
Oh, I don't remember what the index is, but it on Lance's stuff, it'll say high. You know, it'll tell you high, low, whatever.
Mine doesn't show that.
Yeah, I'm not sure Brookside shows the information.
Yeah, I think Brookside is testing it different than Lance does, Rick, because the one I'm looking at right now, the numbers are 86 and 104. And Lance's
Yeah.
usually don't get above 1.
Right. That's probably just a decimal.
Yep.
See, Carolyn, she knows it. She knows these things. But the point of this, and the whole point of the Haney test was to not just take one measurement, like for example, just nitrate nitrogen or orthophosphate or ICP phosphate, and just say, okay, here's this. It's like, no, we're looking at, when we give out recommendations for NPK and micronutrients, we're looking at not only the chemistry of it, but the biology also. So there might be 6 or 7 things that get looked at before there's a phosphorus recommendation or a nitrogen recommendation. And so, this is not just a one shot, here you go. This is an integrated approach to looking at your soil as a living system. Is it cycling? Is it working? And it's a very conservative system. In other words, I used to work for farmers for a long, long time when I was younger, and their biggest concern was always, do I have enough fertility out there? I mean, and I understand that. So this system was designed that if it says you can reduce your nitrogen by 30 or 40 pounds, you can, because we've been conservative in our estimate so that we don't ever under fertilize. That's because I know that's a tremendous fear for most farmers, or at least the ones that I work for. So, if it says you've got this, then it's there.
We have another question in the chat from Clint Lease. He would like an explanation about the CO2 respiration and with the water exchange, organic carbon and nitrogen numbers. He says the pasture that wasn't farmed for 35 years has high respiration, but the other 2 are in the low category.
Okay, that's a good question. So that's an interesting one, because I don't know if Brookside does. Carolyn, does Brookside do a percent MAC calculation?
No, they don't have a percent MAC on here.
Okay, so on Lance's stuff, we give out a percent MAC, and all that is, and I love that little calculation because it's your respiration divided by the water extractable organic carbon, and it's expressed as a percentage. And we like to see that above 50%. And so in that case, yours would be well above 50%. And what that means to me is, here's this carbon pool that's water soluble. And if the microbes really like your carbon, that'll be a high percentage score. If they don't really care for your carbon that they're seeing so much, then that'll be a very low percentage. 20 or 30% of the carbon that they see, they release to CO2. If they see 100 part per million water extractable carbon and their respiration 200, that means they really like that carbon, and they're getting actually more than we're measuring, because the water extract is a one-time extraction. So we just extract the soil and run it on that machine. Whereas the respiration test get those microbes get 24 hours to chew on that carbon before we measure. So that MAC number, and you can calculate that yourself. I mean, that's just 1 day CO2 divided by WEOC and then times 100. And so I think that's a really critical value. And just because you have low WEOC and low organic nitrogen, you have high respiration. That usually means that your system is really functioning. It's so that there's not a lot of nutrients laying around, that they're in the system. They're in the microbes, they're in the plants, they're in all these things. So that's a good sign from my perspective.
Rick mentioned earlier the geographical importance for these numbers, but the time of year is also really important for some of these too, especially CO2 respiration, WEOC and WEON. We have been doing weekly soil sampling on the Hora farm for, I think this is year 7 now, 7 or 8. And what we've found on all of these numbers is that we really see them change significantly throughout the year. You guys pulled these samples in early to late April, some of you early May, but the key thing on that is that your CO2 respiration and your WEOC are not going to be very high early in the year. It's cool, the soil is probably still pretty wet, so that biology is not awake and going and doing anything yet. So if your numbers are showing lower now, it's likely that if you went and pulled the soil sample again today, the numbers would be way, way higher, especially on those 3 that Clint asked about.
Ladies and gentlemen, that's why Carolyn gets the big bucks.
Context is everything, guys.
So Jan is asking when the best time to pull the samples is, but before we move on to that, I'm just going to ask Clint if you feel like your question, if you understand the answer to the question, or do you need more clarification? While we're waiting on Clint, Jan asked when's the best time to pull samples? Caroline or Rick, do you?
So yeah, so it depends on the goal, and obviously logistics are important here too. I prefer that people pull samples in the spring, as close to, planting or emergence as possible. It obviously gets pretty difficult to get through the field and pull soil samples the later in the season we get. So in the springtime is good. The important part about it is that you can pull the samples whenever you want. You can do it in the dead of winter if you really want to, as long as you're consistent. Because like I had mentioned, a lot of these numbers change pretty significantly throughout the year. So if we pull a sample in April and then we pull another sample in July, we're going to see drastically different numbers, and we're not comparing apples to apples anymore. So it's not, there's not a perfect time to pull the sample in terms of the results. It's more the logistics of getting the sample taken that come into play. But, if you pulled it in April this year, when the soil temperature was about 50 degrees, try to do it same time frame next year.
I've wondered though, does it make sense if you really want to follow the soil health on your farm to do a spring and a fall test?
You can do a spring and a fall test. We have some people who have done that in the past to try to see how much your soil health has increased in one growing season, but you're not comparing the same thing, because in the fall, you've now, gone an entire growing season of putting a bunch of organic carbon into the soil. Your microbes are moving and grooving. So it's not quite the same. And Rick, maybe you can speak to that better, but for consistency, once a year, even once every other year at the same time frame is much better.
Well, and I'll say this, the test was actually developed to help farmers understand that they might be able to cut back on some nutrients. So the test was actually designed before fertilizer went down to pull samples, just like a standard test. It's like, what do I have here? Even though your microbial activity and your WEOC and WEON might all be all that revved up, we're still going to see nitrogen that, because the standard test doesn't test for organic nitrogen at all, 0. So you're still going to get some credit for that, even if the system isn't revved up completely. So again, the idea was to let the biology help us understand that we could do some nutrient reduction here without hurting our yields.
Usually,
Go ahead, Carolyn.
oh, I was just gonna say, a lot of our like standard farmers that we have in our program, they like to have us pull samples in the springtime of the corn year. That way we can really get that side dress nitrogen recommendation dialed in. And then we'll use those same samples to write P and K recs for dry fertilizer in the fall.
Yeah, and it was said earlier by one of you, and I think reiterated in this statement here, that like, you know, the soil test really isn't a competition to see like who has the best soil, because it really does vary on when you pull it. And so like that, just understanding that for peer groups is that it's you know, designed to help you understand your soil and where you want to go with it. There's a really, there, Clint did a follow-up too. So his question is, if my WEOC is 118 and 127 is the respiration, that's 92% if I did this right. But the WEON is 6.9, so that's only 5%.
Okay, so the MAC percent MAC I was talking about is just respiration and we are not the water extractable organic nitrogen. If you take what were the numbers? What was the WEOC 118?
So yeah, it's in the chat. I don't know if you could see that, if it'd be better if you look at it versus reading it, but he says his water extractable carbon is 118. And then he says 120.
Oh, okay. Yeah, I got you. Yeah. So Brookside, I don't like the way they do their WEON. So we see a lot of samples that the WEON is way too low because of the way they analyze it. And that's, so your C to N ratio there is going to be kind of out of whack compared to what it really is. Let me see here if I can get my calculator up. My brain's not working very well.
Yeah, and while Rick's figuring that out, just a little explanation on why we went with Brookside. When we were talking about contracting with Mitchell to help facilitate these Haney soil tests, there was a more than one choice on a lab, and we did make the choice to go with Brookside because it's a local Ohio company, and we were kind of hoping that it would facilitate more people using it to be a local company. So I'm not sure, maybe.
No, that's fine. That's not a problem. It's just that we want to get the right information out there. So
and maybe there's a little opportunity for Brookside here to educate them about how they display the results to be more useful.
Yeah, well, I've talked to them over the years and it didn't really get anywhere. So, but anyway, so
Maybe
this would be a
person we can talk
C
to.
to N ratio of 17 to 1, which is too high. That's, so the WEON is too low. And I'll give you a little background on that real quick. So when we first started doing this, there was a machine that we needed to be able to do this. All right. It didn't exist like 15 years ago. And so we're using a carbon analyzer that is based on analyzing water samples. That fit really nice with a water extractable soil, right? Because it's real sensitive. So this machine measures part per million. Most carbon nitrogen analyzers measure percent carbon and nitrogen. Those are wildly different. So the machine that measures water extractable stuff is super sensitive. And so and a lot of labs didn't want to make the investment in buying the super sensitive machine and tried to stick with their old machine that does just solid soil sampling and gave them percent numbers. Well, that's just not a good way to measure it. It's not sensitive enough. And so there was a lot of labs that just stuck with, they didn't think this soil health thing was real. They didn't want to make the investment in the right machine. And then I think later some of them did. And then we had some other scientists that were saying, oh no, your carbon to nitrogen ratio should be your water extractable carbon divided by your total nitrogen, which is not right, because what we're looking at is organic carbon and organic nitrogen. That's what the microbes see. So there was a whole lot of confusion early on, way back when, about that. And, the numbers should work. So what we do, boy, I'm going to get all into this now, aren't I? Is when we take your water extract, we run that on that carbon and nitrogen analyzer for water, and it gives you a total nitrogen number. We take that same sample, the water extract sample, and run it on a machine that gives you inorganic nitrogen, ammonium and nitrate. So we have total minus inorganic leaves you with water extractable organic nitrogen. Those numbers should fall in there, in the range of 8 to 13 to 1, something like that, the C to N ratio. When we get numbers that are higher than that, like this one is 17 to 1, that might, kind of be an indicator that it might not quite be right. However, this is the fun part about biology. There's just no solid answers, it seems. If you're in a native range or native pasture situation, you're going to see higher C to N ratios, where this number, this 17 to 1, would be appropriate for a pasture or a native rangeland system, because they're more efficient. So you don't have a lot of nitrogen laying around because it's always being cycled. Hence the high respiration. I know that was a lot. I don't know if that helped or hurt.
I got one last question. I gotta get going here. I gotta go to FSA, but who do I get to go over my test with? I got these are the free tests that were given out at the one meeting, but I've got the information here now, but I don't understand it at all. And my elevator, the fertilizer company I deal with, Legacy, they don't really understand these tests either. So I don't know who to go to. Matt helped me get started on this, so I don't know if he's the one or someone else to go through this with me, my individual.
Well, Matt farms, so that's who I would be talking to. I mean, this whole idea here is that, it's fine for me. I mean, I used to farm and all that, but I'm not, I don't farm anymore. And I think it's so important. I remember way back when the Nova Foundation started the Soil Health Institute, my suggestion to them is have the farmers teach the farmers, because they understand, right? I've got that stupid PhD behind my name, and it's like that automatically disqualifies me to talk to a farmer. But I want the farmers to teach the farmers. That is just so more impactful.
Okay.
So, I don't know if you have any input here. I mean, Gary, what we want to do is find anybody who wants to learn more, and then we're all going on this journey together. So Matt, do you want to say anything?
Yeah, Gary, I'd be glad to sit down with you and help you with your soil test. Also, the last video that we did, Mitchell and Carolyn did a really good job of, sitting down with our soil test and explaining it. And I'd be glad to sit down and watch that with you, and we could go through it step by step. But yeah, any way I can help, I'm glad to help, Gary.
Okay, I might get a hold of you then.
Sure.
I've got to bug out though now, so.
Okay, good seeing you.
Yeah, we'll see you, Matt.
Thank you.
Bye, you guys. Thanks.
Yeah, any
Rick?
more questions? And I know, Matt, I thought you had some too.
Yeah, for the CO2 burst, what would you suggest? How can we improve that? Is there any specific cover crop mix that we can utilize to help improve that, or what's your thoughts on that?
Well, before I retired, we did this study with green cover seeds. You'll like this. So they had the research plots out there. And so we got them to pull those plants up by their roots. Just pull the plant up. And all these different species, right? Mixed species, single species, all this stuff. And when they pulled the plant out of the ground, a certain amount of dirt stayed on the root. We had them pull the plant out of the ground and then shake that root so that the dirt right around the root fell into a bag. And we had them pull 6 or 7 plants to get enough sample, and then we analyzed that with the Haney test. And what was so interesting about that is it showed, certain plants really increase the soil respiration. And what my vision was for that is that if we could do that on a bunch of farms, then we could let the soil pick the cover crop needed to do whatever, increase your organic nitrogen, your respiration, or your weoc, or whatever. And in that soil, now that was in Nebraska, but the number one cover crop that increased soil respiration was Egyptian wheat, which surprised me. And so any plant that, excuse me, buckwheat's another good one. It gets in there and has a real fibrous root system. A lot of those cereal grains, rye does a pretty good job of that. So, that's just kind of something you have to experiment with. But I really like the cereals for increasing respiration because they put a lot of carbon in the system, and microbes need carbon 10 times more than they need nitrogen. So those grasses really should help do that.
Is there any specific soil type that you've seen improve more quickly?
Well, I can tell you at the research station, we had what was called a Houston black clay. It was 55% clay and pH 8.2, which is like the worst soil in the world to do anything on. And we saw buckwheat, millet, sunflowers, which are native plants really seem to help. And so if you can do a little research in your area for what's native that you can find in a cover crop mix, it might be nice to add a few pounds of that to your mix. They seem to respond to that.
Okay, so if we're really committed to this and maybe some ground that we own, this is a good opportunity to continue planting wheat so we can get a more diverse mix afterwards.
Yep. Yeah, because the whole idea, and I should have said this earlier, of the Haney test and all the stuff that I've ever done is we want the soil. We want to do a series of testing and a series and research that lets the soil tell us what it needs. I think that is so much more accurate. I think that's such a better approach than us just, trying to decide this is what the soil needs. Well, the soil's out there and it tells us something by what grows on it, how this nutrient cycle, what's going on. Our job is to understand where it's at and what we can do to help it. So I have a very different perspective about soil in that I want to ask it the questions and let it tell me if that's possible.
Hey, Rick, I have a question for you. You talked a lot about the biology of the soil. Do you do direct measurement of the microbiology of the soil? Or are you basically looking at the relationship between your chemistry extraction and the biology?
Yeah, so like the respiration, we don't know who's there. We don't know what microbes are doing what, right? That's where PLFA and some of this DNA analysis comes in. That they're trying to identify that. We're looking at a holistic program and how that's related to the extractants and the water extractable stuff and the respiration. We're trying to let all that tell us what's going on. If I understood your question.
So when, as people are trying to sort through what biologicals to add to improve their system, this is telling you, it's giving you holistically how much biology is there, but this is that your results are really not going to guide anybody towards a biological package to improve their system.
Right. And we've seen a lot of samples come through the lab. And when I was with ARS, I analyzed a lot of them where they had put biological products on and, tested with and without. The problem was, and I kept trying to tell these folks, it's like, look, if you're going to surface apply a biological product and then take a 6-inch deep sample, you just tremendously diluted the effect. So my advice to them was, if you're going to put a biological surface apply a biological product, then take a 3-inch sample. out of 6 or 12, take a 3-inch sample. Because the effect is going to be pretty near the surface if there is one. Does that make sense?
Yeah.
Yeah.
Have you seen results or looked at results that by different crop rotations we had on the same soil series?
Yeah, well, we had 150 acres at the research farm where we had conventional till, no till, and rotations. And then others were just straight up, conventional with no rotation. And yeah, we saw all kinds of differences with that when I was really developing the test, because I wanted to see how sensitive it was. And we saw that sensitivity damn near a little bit too sensitive at times. So yeah, if you do a crop rotation instead of just monoculture, that difference will show up. That's why the covers are so important. If you're growing cash crops and cover crops, cash crops, cover crops, that's a better way to do it. And I'll say this last thing. So when we do just monoculture, we are selecting in our soil for a certain group of microorganisms. If it's just monoculture, monoculture, monoculture. When we get a diverse cover crop mix in there, then we bring a whole bunch of other microbes to play that can do other specific functions that we're missing out on. And that's a really important aspect of soil. If you leave a piece of soil alone, it's going to bring in all kinds of diversity because that's what it does. And there's a reason for that. I think the plants farm the microbes. And I think that's why the diversity is so important if you can put that in your rotation.
Okay, we probably we might be cutting it close, but we probably have time for one more question. If there's somebody here that's, staying quiet, but you have some burning question, we'd love to hear from you. I'm doing the thing teachers are supposed to give a pause to give those more shy students their chance to ask something. Oh,
What's the best way to utilize this test for figuring out a nitrogen rate for corn? Want to go in there and do another Haney test right before you apply the nitrogen?
Yeah, that's what I like to see, and that's why we developed this. This actually the test was developed to account for all the nitrogen instead of just a fraction of it, and the correct phosphorus, potassium, and micronutrients based on the correct extractant. And so this test was really developed to help with fertilizer inputs. The soil health stuff came later because NRCS really wanted to be able to score all this, and so I developed all that later. But in the beginning, it was like, oh well, standard test says you have 20 pounds of nitrogen. The Haney test says you have 40. So you can put on 20 pounds less. It's just simple. So yeah.
Rick, can I ask you something before we end our call? I want to respect everyone's time because we did say it would be an hour. That's not the end
Sure.
of our learning here. So if you're on here and you still have questions, you don't understand, the main person to contact would be Matt. And then Matt's gonna, get together, figure out who we'll find the answers to your questions, even if we're figuring them out together. But I guess in closing, I'd like to know, Rick, do you have I know this is a really complicated test, but is there any written document or kind of like a shorter kind of like cheat sheet on how to understand the test that we can provide to people?
Yeah, if you go to Lance's website, Regen Ag Labs, there should be some explanations on there. Should break down each component of it and give you like a paragraph on what it means and what's going on, how we see that. And the fun part is This is a complicated test compared to the standard test, but when they really start rolling out the DNA analysis, you want to talk about complicated. So this is a bridge. So it's important to take this step to start understanding the biology and the chemistry and how they interact together before we dive off into the DNA analysis, which is coming. But yeah, I should be able to find that on his
So
website.
you said that's on the regen, what is the?
Aglab.com. Yep.
Okay, okay. Well, I normally after we do a meeting like this, I do have it recording. And so once that uploads to me and we get it on our YouTube, then I will include that in an email to everyone who registered along with that regen ag information. And then what we'd like to do is if we see gaps in like the understanding of it and we can figure out ways that will help people use their test and understand more, we'd love to now I'm not saying we're doing this, but we would love to develop those resources. So that's what the Nature Conservancy and this program's here for. So like if you're seeing like there's a gap right here in understanding the test and how a farmer can use it. And as we're working on it and we're figuring out how farmers can use it, if we could accelerate that process for other people by providing that information, that's what we would like to do. So when you come across those situations, let us know so we could knowledge share with each other. Does that make sense?
Yes.
Anyone, Caroline or Matt or any of the participants have anything to say in closing before we end?
Just like Stephanie said, if you have any questions, feel free to contact me. I'd be glad to sit down with you and learn more together.
I know a few of you, Stephanie had emailed Mitchell and I about sending your results again. Mitch has those on his computer, so we will get those to you as soon as we can.
Yep, he is, they have a new baby, and so he's really busy with that right now. So we're gonna, maybe it won't be as quick as in a normal day for him. Okay, thanks everyone. Have a great day.
Can I just ask Rick one question before he leaves? Nobody else needs.
Sure.
Yeah, and Matt, I wanted to chat with you a little bit too. We could stay on and then if it goes too long, we'll get our own Zoom. So
Sure.
thanks everyone. And Brandon, I noticed you just joined. You're on mute.
Yeah, sorry, I was late joining.
Yeah, I didn't know if you had the time wrong, but we recorded it, so I'll send you the recording.
Perfect. Hey, long time no see, Rick.
Yeah. How about that?
Yeah. Yeah, sorry, I just got back from dropping the kids off summer camp. So
Fun.
yeah.
Okay, Jan, I don't know, Rick, we said it was gonna be from 8 to 9, but I don't know if you
I'm
have
all right.
another commitment.
Go ahead, Jan.
This is crazy, but it's not related to the test, but to the soil health. When we were transitioning, I ended the contract with my conventional farmer, and my new farmer and I are really partnering with this whole thing about soil health, cover crops, et cetera. But when we were doing that transition in the spring, we had the 3 winter annuals come up, and I was just a newbie at that. Since then, I've taken a couple classes at Ohio State, and I'm just really trying to get on board with all this. But my conventional farmer he saw that and he just wanted to come out and spray everything. And I'm going, no, wait a minute. No, until I find out what these are on my field, you're not doing anything. Well, that did not make him a happy camper. And so I pulled in my new guy. He said, no, I wouldn't spray them because they're already, they've only got 2 more weeks of shelf life left. But my conventional farmer was concerned that these 3 winter annuals, and I don't remember the name of them now. I think one was henbit. Does that sound right?
Yeah, henbit, purple dead nettle is
Yes,
probably the other one.
Thank you. Were they really pulling a lot of nutrients out of the soil?
No.
Okay.
Now, so the biggest kick on all the cover crops, like, well, they're going to use moisture. Yes, no kidding. That's a brilliant argument. It's not a brilliant argument. I was being sarcastic. They are going to use moisture, but
Okay.
once we get the covers established, and we saw this, over the years, there's that little hump you got to get over, right? Because once they get established and start covering the soil, I mean, you stick a thermometer into the ground and it's 20 degrees cooler. What do you think happens to the water in a soil that's been plowed to death?
Right.
I mean, it's, So we want the water to move out of the soil through transpiration and not evaporation.
Right.
And that's where the cover crops are so important. And they also, like you were just talking about, oh, they're sucking all the nutrients out and, you know, there won't gonna be any water or nutrients. That's just, none of that's right. It's not
Okay.
right.
That's what I thought. Last year, we had an incredible biomass laydown of crimson clover. Just incredible. And we didn't use any fungicide, herbicide, or pesticide all year. That was nothing. That biomass took care of everything.
Yep.
So
That's the idea.
it's working. All right,
It's a
thanks.
you know, but here's the thing. My great grandparents used cover crops. They, you know, they knew that. This is not new.
Oh, it's
This
not.
is something we're relearning.
We're mimicking Mother Nature. Yeah.
Yep, exactly.
Thanks. It's been an honor to have some time with you. I've read a lot about you and your name, so thanks.
Yeah, well, you know, we're transitioning to the smarter half of the Haneys, and so Liz is, you know, stepping in there.
I love the shirt Liz is sending me.
Which one?
Her latest one, the regen farmers have bigger worms.
Yeah, she really loves that one.
Yeah, that was awesome.
Yeah.
Well, hey, sorry I missed the call.
Yeah, no problem. We'll send you the recording. And yeah, if you have any other
good.
feedback, just email us or let us know.
Will
Thanks,
do.
everyone. Thanks for attending. We really
Thanks, everyone.
appreciate your
See you,
time.
Rick. See you, Carolyn.
Thanks, guys. Bye.
See ya.
Thanks, Carolyn. Thanks, Rick.
Yeah, thanks.